we're going to work on factoring large polynomials here. And the reason I call it large is because it's got a degree of the leading coefficient of 3. Otherwise, we could use some of our factoring tricks. If it was anything lower, like 2 or 1, we could use factoring. We could just use some simple algebra to solve for x. But this one, we got to do a little bit of a guessing game. Factoring happens to be a hard problem in math. So what we need to do is kind of find one of the original factors, which we can do by a bit of trial and error. Okay? And one way to do it is just trying to find out what value we can plug in that's going to set this equal to 0. And then we can do some factoring from there. One of the methods is to take the constant, that's the last term here, and use its factors. So we have like 24 here. We could use 1 and 24, 2 and 12, 3 and 8, 4 and 6. Technically, I can use fractional ones too. So I can start to use fractions. So there's like an infinite number of factors to use in here. We're going to start off with these as educated guesses and hope that they work out. So in other words, what I do is I'm going to rewrite this equation as a function. And I'm going to say f at x is equal to 3 cubed minus 9x squared plus 26x minus 24 is equal to 0. Whoop, not equal to 0. What am I saying? It's a function. And what I'm going to try with is I'm going to try plugging in the value of 1. I'm just going to go through them all. So f at 1, what does that give us? That gives us 1 minus 9 plus 26 minus 24. That kind of gives us negative 9 minus 24, 36. That one's not going to work out. It's not going to equal 0. What's that going to equal in the end? I think it's going to be something like 10-ish. So not a factor. And to be a factor, it needs to equal 0. So we're kind of trialing error in our way through this, okay? I can try the number 24, but I'm going to try some simple numbers that I can probably do in my head before I start getting to things where I'm going to need calculators. That's just an efficiency trick. We're kind of taking the shot in the dark and guessing here. Here, 2 to the power of 3 gives us 8, minus 9 times 2 to the power of 2 is 4 times 9 is 36. 2 times 26 gives us 52, minus 24. Already, this is not quite something I'm going to probably do in my head here. This is going to give us negative 6. That's going to be 30, 40, 50, 60. Oh, actually, I think this one worked. I'll break it down a little better here. We'll do 2 at a time. 8 minus 36 would give us 28. Negative 28, I believe. Yeah. And then 52 minus 24 and 25, I believe is 28. You can double check that for me. But negative 28 plus 28 gives us 0, which would mean 2 is one of our factors, okay? You double check, make sure I did that correctly, but I believe 2 is going to be one of our factors. So what we can do now is we can set up some long division. Because it's positive 2, so we know x is equal to 2 in this case. So I need to turn this into a factored form. Well, if I just bring 2 to the other side, I get x subtract 2. And x subtract 2 will now be part of our long division for this polynomial. So now I can write this polynomial like this: x cubed minus 9x squared plus 26x minus 24. And now I'm going to go through some of my long division to solve this, okay? My very first value here is x. I need it to become x cubed. Well, in order to do that, I'm going to multiply by x squared. And when I do that, I'll get x cubed minus, negative 2x cubed, negative 2x cubed. And then we subtract the 2. This one creates a 0, 0x cubed, which is the same as saying nothing. Negative 9 subtract negative 2 is the same as negative 9 plus 2, so we get negative 7x squared. Then we go to the next part. How do I make this x negative 7x squared? Well, I multiply by negative 7x. When I do that, I'll get negative 7x squared, and then I'll get positive 14x. Now, I did forget this part. I'm going to bring down that 26x. Okay? And then when we do that, we again subtract them, And when we subtract the 2, -7 subtract -7 cancels these two out. We end up with a 0. And 26 subtract 14 is going to be 12. 12x. Let's bring down that -24. In our very last step, how do I turn this x into 12x? Well, I multiply by 12. When I multiply by 12, I'll get 12x minus 24. When I go to subtract the two of them, 12x, subtract 12x is nothing, and -24, subtract -24 is nothing. We get a remainder of 0, which is great. That means that was a proper factor. And more importantly is we can now rewrite this question as x minus 2, and then we're going to use our quotient there, x squared minus 7x plus 12. Now this isn't solved, this is just one of the factorings here. But they probably want us to factor this whole thing out. Well, we can actually now just focus on this. This has, I should have used a bigger highlighter. This has become a quadratic. I have a couple tricks to doing quadratics. Technically we do quadratic formula, but I think this might be one where we can look for two numbers that multiply to positive 12, and those same two numbers are going to add to -7. And if I do -4 and -3, that works out really nicely, which means this factors into x minus 4 and x minus 3. So I can rewrite this entire function now. I bring down the x minus 2, and then I add in my new x minus 4, x minus 3. And what does that mean? What are our possible roots? Our roots are x is equal to, and I just look for the opposite signs because there's no coefficients in front of x, are 2, 3, and 4 in this question. Let's see. We'll look at everything at once. So a bit of work. We had to do a little trial and error. Once we found a factor, we tested it. We put it through polynomial long division. Once we did that, we ended up with a new one where we had a quadratic. We used some product sum factoring, and we were able to find our x values as 2, 3, and 4 in this case.